Okay, so for 9-2 day 2, I just kind of want to go over again what exactly a confidence interval means, what is it trying to say, what does it mean when it's 90% confident, and then kind of go over the steps again, just so you guys can kind of get a full understanding. If you have a calculator, again, make sure you have a calculator out. If you want to have the purple sheet, you can. The formula sheet you don't really need today, but these two would be important. So, what factors affect your margin of error? So the length of the interval. There's two things you really have to focus on when you're thinking about the length of your interval. Remember, we're trying to guess the population parameter. So it can be as wide or as small as you want. The first thing is your confidence level. If you want to be really confident, you can do that. You can increase your confidence level, but this will give an interval a better chance to capture that parameter, but it have less precision. So you will have a larger overall interval, but you may not be it'll be less precise, so your margin of error will be bigger. Or you can change the sample size. If you want more precision, you can do the opposite. You can increase your sample size, but this costs additional time and money. So this way you get a smaller interval. For a lot of art stuff, because it's theoretical, changing the sample size is nice, but in the real world, you wouldn't necessarily want to change your sample size, because if I want to take a sample of 30 versus 300, that's going to cost me additional time and money. So maybe I'll just change something else. So those are the two things that affect your margin of error. Those are the only two things that we can really change. So the other big thing is how to interpret your confidence level. So I'm going to kind of do a little activity. It's supposed to be for the whole class, but we're going to do it just with me, and then I'll tell you what happened last year. So suppose that we assume that 42% of all students at Salem High School have a tattoo, and we want to simulate a random sample of size 200 to calculate a 90% confidence interval for the proportion of Salem students with a tattoo. So I'm asking you all to go out and take a sample of 200 and ask them, do they have a tattoo? So first we need to simulate samples of 200 students and determine how many have tattoos. So first thing I'm going to do is I'm going to go to Rand Bin in my, let's see if I can find it, list. Math. So I'm going to go to Rand Bin. If I can find it. There it is. And I'm going to do N is 200 and P is, oh, I lost it. So probability Rand Bin 200, and I want a 0.42. So I'm trying to get it 42% of 200 students. So if I put this in, here are the numbers I get out. So my first sample, I had 94 students with a tattoo out of 200. If I hit it again, my second sample will be 86. My third sample, 82. My fourth sample, 91. And then my fifth sample will be 84. Now, if I was here, I would have all of you go through and do 5 of your own. We would have to put in our birthdays so that we wouldn't all get the same 5. If you try and do this right now, you might get the same 5 I got. But since we're not doing it, you can just look at my 5. Now I'm going to look at the 90% confidence interval for my sample. So because I'm not going to do a whole setup, I'm just going to use the calculator. Remember, it's test A, 1 proportion Z interval. And this is going to be my X. So I'm going to find 5 90% confidence intervals for using these 5 as my X. So I'm going to just go to stat, test, and I want 1 prop Z int. And that first one I got 94 out of 200, and I want a 90% confidence interval. So my first was between 0.41195 to 0.52805. So does this capture the 42%? Yes, it does. 42% is within that interval. Now if I go back and do it again for 86, now I have 0.372 to 0.487. Does that capture the 42%? Yes. Go back, do it again for 82. Oops, I missed it. Oh, darn it. Sorry. Can't hit enter twice. .352 to 0.467. Does that capture the 42%? Yes, it captures. Remember, 42%. We're trying to. That's our population parameter that we're trying to estimate. Okay, now I'm going to go in and do it for 91. 0.397 to 0.513. Does that capture the 42%? Yes. And then last one, if it changes to 84, I get 0.362 to 0.477. Does that capture the 42%? Yes. So how many of your 90% confidence intervals included the population proportion? For me, it was all of them. Okay. Now if we look at the class as a whole, so let's pretend I made all of you do these different five. So you have over 100 confidence intervals since there's like 30 of you. When I did this 2 years ago, or last year, as a class, we had 30 people, so we had 5 times 30, that was 150 samples. And as I walked around, 137 of them had the 42% within that interval. So what percentage of your class's 90% confidence intervals included the population proportion? So if I take 137 out of 150, that gives me 91.3. So we had 91.3%, which is close to 90%. Now, every year when I do this, it's usually somewhere close. Like a couple years ago, I got 88. Last year, I got 91, probably close to a 90. But it should be somewhere in that 90% range. Obviously, it's not going to be perfect, but the more confidence intervals we did, the closer we should get to 90%. Okay, if I were to collect all of them from like the last 5 years, I could probably get close to 90%. So here it was 100 because we only had 5. All of them included the 42%. The more you take, the closer you get to that 90% confidence. So that's where that 90% comes in. Okay, so when you're interpreting a confidence level, so in other words, what does the 90% confident really mean? This is what your interpretation is. In the long run, 90% of all the intervals produced with this method will capture the true value. And the reason we say the true value is because eventually we're going to be looking at capturing means. Right now we're just focused on proportions, but we'll also be doing means. So it might change. So think about before we gather our sample, there's a 90% chance that the sample we will obtain will produce an interval that captures the true value. It does not mean that there's a 90% chance or a probability that a particular interval captures the true value. It's either in there or it's not. This wasn't going to be 90% probability. It's either yes or no. It's either 100 or not. So you really want to make sure that you understand this first one. What does a confidence interval mean? Because it's going to be asked a lot. So don't say there's a 90% chance that the interval from 0.05 to 0.13 captures the true proportion. Rather, you want to say the 90% confidence level refers to the method used to construct the interval rather than any particular interval. So like, we all did the same method. So overall, in the long run, 90% of all of the intervals should include the true value. So now let's just take another day and go over the steps to get credit on any confidence interval problem. So this is going to be like for the rest of the chapter. So for listing, the first thing you have to do is list all the conditions and whether or not they've been met. So the first one for now is you want p hat is from a simple random sample. Or sometimes they'll just say it's a random sample because it could be stratified. So p hat's from a random sample. The second one, you want to always check your central limit theorem. So n times p has to be greater than or equal to 10, and n times 1 minus p has to be greater than or equal to 10. Therefore, by the central limit theorem, our sampling distribution is approximately normal. To get credit on this step, I need to see the work with numbers and the sentence. So you want to make sure in here you use numbers. Okay? Step 3, condition 3 is always to name the type of interval. For now, we're just doing a 1 proportion z interval. And then step 4 is to define the parameter. So it's usually p equals the true proportion of, and then whatever, of students in Salem who have a tattoo, something like that. Then for the testing part, usually this is 4 points. So 1, 2, 3, 4. So there's usually 4 points here if I'm grading you on a test or quiz. Then you want to list all the testing part, list all the pertinent data, anything mean, standard deviation, sample size, a z critical value. We'll get to degrees of freedom later. Calculate the confidence interval, including the formula. You have to include the formula with numbers plugged in and the final confidence interval. It's fine to do the final in your calculator, but you have to include the formula. If you just give me the interval and without the formula, you will lose points because the AP test, you have to have both. So this is usually 4 points. So usually it's with the formula, giving me the interval, and then list all the data. And then your conclusions, usually 2 points. And again, it's really a fill in the blank from yesterday. So, and you make sure you do it in terms of the problem. So we are blank percent confident that the true whatever is between whatever and whatever. And this part should go back to up to 4. The true, and then whatever you wrote here, write it again. Seems repetitive, but this is what you need to do because this is how they check for the AP scores, and if you do all of this, you get 10 points every time. So I know it seems like a lot, but we're going to be doing this a lot, so you might as well get comfortable with it now.